Here's a typical horizontal projectile type problem. A ball is pushed off a high tower with a horizontal speed of 6 meters per second, and it lands 1.8 seconds later. You can see a snapshot there just as the ball lands on that green ground. The green arrow represents the horizontal component of the ball's motion, its velocity, and the blue downward arrow represents the velocity vector component of the ball's motion downwards. Now what we're asked to find here, we're asked to find the vertical speed of the ball just as it hits the ground, we're asked to find the height of the tower, and we're asked to find out how far from the foot of the tower the ball landed. So quite a lot of things to find there, and to do this we have to rely on our two motion graphs for the velocity. That's our vertical velocity and that's our horizontal velocity component for a horizontal projectile. You can see the horizontal velocity stays the same, so we can be sure that it's going to be exactly 6 meters per second all the way throughout that journey until it strikes the ground. But the vertical velocity is going to increase from 0 all the way up to whatever value the velocity is at that particular time of 1.8 seconds. Now it's from these graphs that we can work out all the answers to those three questions that's been posed to us. So we'll start off with the vertical area first of all. We'll put the horizontal graph to the side and we'll work on the vertical velocity graph, this one here. So we can start to fill things in. We know that the journey ends at 1.8 seconds. And our job is to find the speed here, which is exactly the speed downwards, the magnitude and size of the downwards vector of velocity at 1.8 seconds. Now to do that is dead simple. All we have to remember is that the velocity at any particular point is equal to the acceleration times the time, provided that the initial velocity is going to be equal to 0. So in the case of this horizontal projectile, that is the case. The initial vertical velocity downwards is 0. So we can choose to ignore that and just simply concentrate on v equals at. So v is going to equal to the acceleration of gravity. We just take its size, 9.8, and it's going to be meters per second every second, multiplied by the time, which is 1.8 seconds from the graph, and we now have the velocity at that particular point in the journey, and it's going to be equal to 17.6 meters per second. It's that simple to work out. So we can fill that in our graph, 17.6 meters per second. So we've done the first part. What about the height of the tower? Well, we know the area under the speed time graph is going to give us the distance travelled by the ball. So the area under the vertical velocity time graph is going to give us really the displacement from the top of the tower downwards, which is really the same as the height, the distance travelled. So we can work out that area. We've got the height of the tower, or the height where the ball came from. Now it's a triangle, so all we have to do is work out the area of it, and the area is going to be equal to 1/2 the base times the height. 1.8 is the base times the height of the triangle, 17.6, and we work that out. We get a value of 15.8 meters, nearly 16 meters. So we know that the height of the tower is about 15.8 meters, or 16 meters if we want to go to two significant figures. 15.8 meters is the height of the tower, found from our vertical velocity motion graph. Now, how do we find how far from the foot of the tower the ball landed? Well, that's this distance in here, and that's given a special name. It's called the range of the projectile, the horizontal range of the projectile range, and that's from the foot of the tower to where it lands. So how do we find that one out then? Well, we rely on the horizontal velocity this time. And there's the horizontal velocity graph. Now we can fill in the details for that. We know that the horizontal velocity is going to remain the same. It's always going to be 6 meters per second, so we'll have a 6 here going along that line, 6 meters per second. And we know the time is going to be 1.8 seconds that it landed at. So the range, being that horizontal distance, yes, you've guessed it, can be found by the area under that graph like that. It's a rectangle. So therefore the area has got to be equal to the length, 1.8 times 6. And we work that out with my calculator, we get 10.8 units. And that translates as a range of 10.8 metres. So there we have worked out those 3 important questions just by relying on our knowledge of our graphs. You must know the horizontal velocity graph. You must know how to work out the area under the graph to give you the horizontal distance travelled by the ball or the projectile. The vertical velocity graph is a wee bit kind of harder, but you know you can find the velocity at any particular point in time, this point here, by knowing the equation which is v equals at. That gives you the velocity at any particular point in that journey. So 1.8 seconds, we plug it in, A is going to be 9.8, and we can get the velocity at that particular point. So knowing well your 2 graphs will enable you to work out the problems of these horizontal projectiles.